Hello everyone, so today I am presenting the result of a study that took months of computation and tested a simple but audacious questions. Does the geometry of an 8-dimensional mathematical crystal align with the locations of sacred sites on Earth? The answer, it turns out, is statistically yes, but the reason why remains a complete mystery. So the E8 root system is one of the most symmetric objects in mathematics. It lives in 8 dimensions. It has 240 vertices and 6,720 edges, and a symmetry group of nearly 700 million elements. So we can't visualize it directly, but we can project it, like shining a light through a crystal and casting its shadow. So when we project E8 through an orthonormal matrix into 3D, those 6,720 edges become a dense web of correct circle arcs wrapping the globe. We tested this web against 160 sacred sites, so temple, megalith, pilgrimage centers from every inhabited continent. The sites were selected for cross-cultural significance, not geometric criteria. No one chose these sites because they fit a grid. They were compiled from the sacred geography literature, adapted from Ruber-Kuhn's framework of 156 planetary circles. So here is the trap. If you wrap 6,728 lines around the globe and let a computer rotate them, it will always find some alignment, just by chance. A standard test would declare success when all it found was noise. So you have here on the left panel showing this, a false positive. And on the right panel, it shows our solution, a best of search null model, in which every comparison trial has the same freedom to optimize. So each random trial gets the same freedom to search for its best orientation as the real data did. So we're not comparing our best shot against random blind guesses, but against random data's best shot too. A fair fight. So we're not asking, does the real data align? We are asking, does it align better than the best that chance can do? Each null trial follows 4 steps in this methodology. First, we scramble the real sites using a random rotation. Then second step, we run the full search, 23,328 candidate orientations. Then we refine the best candidates. Then third, the last step, we record the best alignment that chance achieved. So we repeat this 1,000 times. The real data has to beat all 1,000 ghost tournaments to count. So we started with 270 random projections of E8, and after coarse and refined optimizations, 130 were shortlisted. An RMS, what is RMS? It's the root mean square, the average distance between each sacred site and its nearest E8 edge. Lower means better alignment, like a golf score. Gate eliminated all but the most competitive. The fixed rotation null filtered further. And finally, the best of search null, the real test, left us with 4 survivors, 4 out of 270, all with Bonferroni corrected p-values. So what are they? When you test multiple hypotheses at once, you raise the bar for significance proportionally. If you test 5 thresholds, you multiply each p-value by 5 to avoid false discovery. So this p-value was below 0.05, which is significant. So here we have our 4 confirmed projections from the 160 site catalogs, seed 3, 46, 48, and 85. And the effect size ranging from 2.33 to 3.52. So what is the effect size? How many standard deviations the real result sits from the average random result. Above 2 is considered huge, like scoring in the 98th percentile of a test. These are large effects by any standard. Each one found its alignment independently at a different orientation on the globe. So what is remarkable is that these 4 seeds don't all do the same things. Seeds 3 and 85 achieve breadth, 97% of sites within 11 kilometers. Seed 48 achieves precision, 83% within 5.6 kilometers, and seed 46 achieves ultra precision, 30% of sites within just 1.1 kilometers. They occupy complementary distance bands. Each excels where the other don't. So now we come to the razor's edge. How precise is this alignment? We tested by nudging each confirmed seed's orientation by a small amount. So you can see there is some wells on the graph. A displacement of just 5 degrees increases the error by 44 to 72%. The alignment lives on a razor's edge, and when we compare this sharpness against null optima, which are orientations optimized for random sites, the real optima were 4 to 7 standard deviations sharper. The null optima are flat. The real ones are steep, precise wells. So could this just be a property of the E8 metric? We tested with 50 catalogs of 160 random points on the globes. The E8 geometry produces about 47% baseline sharpness for any set of points, but the sacred sites produce 5 to 18 percentage points above the baseline. So Fisher's combined p-value, we got 0.007. So this Fisher's method is a way to merge results from several independent experiments into a single probability, asking what are the odds all of these are flux simultaneously. So the signal is site dependent. It's not just the geometry, it's these specific sites. That's what we came to the conclusion. So now we're coming to the cross comparison. Is E8 special or any geometric shape work? We tested different shapes, icosahedron, geodesic sphere, and the Goldberg polyhedron with the same methodology, same pipeline. All of them produce significant results under the standard test, the Texas sharpshooter test, which is shooting at a barn wall and then drawing the target around the bullet holes, finding a pattern first and then claiming you predicted it. Our best of search null model prevents this by letting random data shoot with the same freedom. But under the best of search null, all of them fail, and only E8 survived search BS correction. So we systematically eliminated every explanation we could think of. First, stochastic noise has been ruled out by 1,000 trial testing. The search BS was also ruled out by full optimization nulls. The metric BS will rule out by null sharpness comparison, and the generic point effects was ruled out by random site control, and the preferred bearing was ruled out by chi-square testing across 270 seeds. So this signal survived every challenge, every statistical challenge. So is it the projection matrix? So what makes the confirmed seeds special? We computed 25 structural features for all 270 projections and trained machine learning classifier to predict success. The result was a value of 0.52 for OAK, AUC, which is a score from 0 to 1, measuring how well a classifier can distinguish two groups. So 0.5 means pure guessing, 1 means perfect discrimination, or 0.52 means projection matrix. Features alone can tell confirmed seeds from failed ones. But that's a coin flip. The confirmed seeds don't cluster on a distinct region of feature space. The projection matrix, taken as a whole, cannot predict alignment. So is it the edge network topology? What about the actual geometry on the sphere? We compared 6,720 edges for confirmed and failed seeds, edge lengths, density, angular coverage, bearing patterns, all identical, less than 3% difference. Seeds 85 and 12 share this exact same anchor point, but different bearings. One succeeds and one fails. So the macro geometry is the same. The difference is in the micro positioning of individual edges relative to individual sites. So we're coming to a fine structure phenomenon. This is the core finding. The alignment is invisible to every aggregate metric we tested. Neither the input matrix nor the output geometry predicts success. The signal resides strictly in the precise angular relationship between individual E8 edges and individual site locations. It's a rather sharp resonance that vanishes if perturbed by just 2 degrees. Now we're coming to a very important characterization of the E8, the dimensions 2, 4 fingerprint. But there is one pattern that distinguishes confirmed seeds. When we look at how each projection weights the 8 dimensions of E8, like an 8-channel equalizer, dimension 2 is consistently boosted. It ranks in the top 3 for all 5 confirmed seeds across both catalogs, and dimension 4 is consistently suppressed. So this is the fingerprint. Successful projections turn into a specific subspace of the E8 root system. So we did a transfer test. We tested the 4 confirmed seeds at their fixed orientation on the second catalog. 62 sites compiled by Robert Kuhn catalog with 77% overlap. None of them achieved significance. the orientations don't transfer. The alignment is strictly bound to the specific spatial arrangement of the sites it was optimized for. So there is a fresh discovery on the 62 site subset. So when we run a fresh tournament on that catalog, same methodology, same pipeline, no reference to the 160 sites results, a completely different seed emerged, seed 89. So different projections, different orientation, different hemisphere, and the RMS p-value is 0.002, which is low. And the effect size 3.87, the largest in the study. Perturbation sharpness 133%, more than double any 160 site seeds. And its dimensional fingerprint, the strongest we've ever seen, dimension 2 at 0.904 and rank 1. Dimension 4 at 0.187, nearly muted. Different catalog, different seed, same fingerprint. So basically, what remains open? We have to be honest about what we don't know. Site selection bias. The 160 sites were curated by a researcher called Robert Kuhn, 156 sites, and I have added I've added 4 second sites, so which comes to 160. And we can rule out that a spatial regularity in the catalog itself drives the signal. Hidden spatial structure, 160 points on the sphere have inherent geometry that might resonate with E8. E8 symmetry inflations with 700 million symmetries. Some orientations may be circuitally equivalent, making our p-values optimistic. Without a causal mechanism, we cannot distinguish a genuine in higher dimensional relationship from a highly sophisticated statistical artifact. So we come to a 5-level research roadmap. So the paper lays out 5 levels of future investigations. First level is the independent replication on geophysical datasets with 0 overlap, tectonic plates, hotspots, and earthquakes. And then level 2 is characterizing the spatial structure of the site catalog itself through spherical harmonics. And then the third level is synthetic catalog experiments that selectively preserve or destroy spatial properties. The fourth level is mapping which specific E8 serve which specific site across seeds. And the last level, which is more exciting, is reverse engineering the 8D directions that the alignment encodes. Each level narrows the explanatory space. So the empirical verdict. 3 things are clear. First, the statistical alignment is real, robust, and survives massive multiple comparison correction. Second, it's a fine structure resonance, unexplainable by any standard geometric aggregate or metric bias. And third, the physical or mathematical mechanism driving this resonance remains an open scientific mystery. The signal is real, its meaning is the question. So I have now written my second paper, extended to this one, which explore the 5-level research roadmap a bit more deeply. So I will publish more articles, podcasts, and an explanatory video like this one to present the results. And I can tell you right now, E8 is much more complex than I thought, and the mystery remains as the synthesizing E8 projections has of a strong dimension 2 and weak dimension 4 don't necessarily produce a strong alignment, but with we found a counter example that produce a strong alignment with a strong dimension 4. So it's not in the dimensional fingerprint that we can explain such an alignment. And I will present in detail those results for the next presentation. And that's it for today. So if you have any question, please feel free to comment and feel free to share this goldmine research work on the planetary grid involving a highly dimensional structure called E8. Thank you very much and see you for next time.